Okay, so we'll do second half of the review here. We did some questions yesterday from the first half of the review. I'll pick it up on number 10. And if you want to follow along here, you can. This is from your review assignment. Some of these questions would be. So number 10 says multiply and express each product as a radical in simplest form. So root 2 times root 6. The rules for multiplying radicals would be the numbers in front, you'd multiply those together, and then the numbers underneath the similar or the common radical. So they both have to be the same index, but you can multiply the numbers underneath if that's the case. So this is just root 12. And we do have to take a close look at this to see if we can simplify. And we can actually, because root 12 is root 4 times root 3. So root 4, of course, can be simplified as 2. So that comes out to 2 root 3. Any questions on that? All right, so just check to see if you have a perfect square as a factor of the number underneath the radical sign. That's called the radicand, that number. All right, multiply and simplify, number 11. So this is going to be a little step up here. We've got binomials, so we'll have to do the FOIL method, right? So the first terms times each other, that's going to be 2 times 2 is 4. Then we have plus root 5, plus 2 root 5. And you might see that this is actually going to be a difference of squares. We've noticed that before, but I'll expand it out. So plus 2 root 5 minus 2 root 5. We multiply these together. And then minus root 5 squared, which is just 5. So these terms cancel out, and we have 4 minus 5 is negative 1. There's no variables in here, so there's no restrictions on the variable. If you have a variable underneath the radical sign, remember that that whole expression has to be positive. So you set that greater than or equal to 0 and then solve for the variable, and that's your restriction. All right, everybody agree with that one? Negative 1, sorry, it should be a negative there, yep. And yeah, if you notice that these were the same terms but opposite signs, it comes out to be a difference of squares. So you could just square the first term, that's 4, and square the second term, that's 5, and then a minus, so 4 minus 5 is 1. All right, number 13 says rationalize the denominator. So to rationalize, we make rational, or we eliminate the radicals. So eliminate the radicals in the denominator. And if we have a single term like this one's pretty straightforward. You just multiply top and bottom by the same thing, and that would be the radical that you see in the bottom. So one single term, just multiply by the radical. And if there's a number in front, you don't have to multiply by the number in front too. You just multiply by the radical term. So it just makes things a bit simpler. Although you could, and I might do a quick example of that afterwards, but so this becomes the square root of 6 times 12, which is 72. And this becomes the square root of 12 times 12, which is just 12. So the square root of 12 squared. Now, we should simplify this as well. It didn't clearly say simplify, but you always should simplify. Meaning we should simplify the radical if possible. And we did a question just like this yesterday, where this is actually 36 times 2. So that comes out to 6 root 2 over 12, which would further simplify to root 2 over 2. Rationalize the denominator. And yeah, so the other example, I maybe will just do a quick one here, just to follow up with this. But like I mentioned, if you have something like 2 root 6 over 3 root 12, let's say. Well, in order to rationalize the denominator here, you wouldn't need to multiply by 3 root 12, just the root 12 part. Okay? So that will be fine, because again, when you multiply these two together, on the bottom there, you're going to get 3 times 12, right? So that's still going to be, you're going to get rid of your radical there. And this would be 2 root 72, which would be, I guess, 2 times 6, or 12 root 2. And then that would simplify 1, 3. So this would be root 2 over 3. Root 2 over 2, root 2 over 3. I think. Anyways, the main thing that I want to show you is this. You don't have to multiply by the number in front as well. Okay, let's move to 14. So rationalize each denominator. So when there's two terms in the denominator, you have to multiply by the conjugate. Make sure everybody knows what the conjugate is. It's a binomial with the exact same terms but opposite sign. So you got to do that to both top and bottom. So the top becomes negative 8 minus 2 root 3 when I distribute this 2 to each term. And over here we have a difference of squares now, so that's going to be 4 squared, or 16, minus root 3 squared, or 3. So negative 8 minus 2 root 3 over 13. And in the textbook here, factoring is not necessarily for these questions, not necessarily necessary for simplification, although you should factor if there's a common factor always when simplifying. So again, that led to some confusion in some of those questions there about simplifying, but multiply everything out and then factor at the end if possible. So we could take a negative 2 out of here, and this is just 4 plus root 3, which we kind of started with earlier, but now you see that this 2 cannot divide out, and if it could, then you'd have to simplify that. So that's why we would factor and just check. So either of these would be okay for an answer for that one. But this would be preferable. Going forward in math, we want to factor to simplify. Just throw your hand up if you have a question or you want me to clarify anything. All right. Okay, let's get into the 5.3. So I just have a couple questions from your 5.3 section here. And identify values for x for which the radicals are defined, solve for x, and verify your answers. So the values for x which the radicals are defined means to identify the restrictions for x that will cause this to be real number answers. So here x has to be greater than or equal to 0, because that's what's underneath the root sign. If I don't have to solve for x because it's already solved for. So there's my definition of my variables that makes this a real number answer. And then solve for x. Okay, so for a here, I'm going to divide both sides by a negative 1 to get root x equals positive 7. And then I'm going to square both sides. X equals 49. And there's your answer, along with this, for a. All right, D is a bit of a trickier looking one, so let's do D. It's got a fraction there, no problem. 7x over 3 must be greater than or equal to 0. We know that. So 7, you multiply both sides by 3. 0 times 3 is still 0. So x has to be greater than or equal to 0, because when you divide by 7, you still get 0. So as long as x is positive or 0, we're okay. Okay, because as soon as x is negative, that makes this whole thing negative, which is not good. So x has to be greater than or equal to 0. So we'll leave that as part of the answer. And then to solve, I'll maybe just move over here and do that. So you have to get the radical by itself, right? So let's get root 7x over 3 all by itself by subtracting 1 from both sides. Now that I've got the radical by itself, I square it. Square both sides. That just leaves me with 2x over 3 equals 49. And now I've got no radicals. This is a simple equation that you solved in grade 7 or whatever, or before. And 2x equals, is that a 7 or a 2? Oh yeah, sorry, my bad handwriting there. Yeah, that's a 7x equals 49 times 3, which is what, 147? 147. And then that should be about 21. X equals 21. And you certainly want to check these. So put a 21 in there and see if that works. All right. Let's just see. Yeah. So any questions about 18? All right, let's finally do 19. This is kind of the top level type question where we've got two radicals. So let's do, well, I'll do a first. So if I have the radicals, they're actually both already isolated, so that's great. So let's just square both sides now. That's going to be nice and easy. This is going to be 5x minus 3 equals 7x minus 12. Got rid of both radicals with one step. That's great. So I'm going to send this 5x over to the other side. That's going to be a 2x. I'm going to send this 12 to the other side. That's going to be a 9. So 7x minus 5x, and then negative 3 plus 12. So x is 9 over 2. Okay, and then you would check by putting 9 over 2 in there, and what would we get? Yeah. Restrictions. Okay, so restrictions. All right, how do we do restrictions here? Well, you have to find out what x can be for both of these, which we haven't really done a lot of work with finding restrictions when there's two radicals. So you have to kind of combine the two. So wherever x is defined for both radicals, like wherever they overlap, that's where the that's going to be the allowable values for x. So it has to work for both radicals. So what I mean by that is 5x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3/5. Also, at the same time, 7x minus 12 must also be greater than or equal to 0. Over 7. So on a number line, 3/5 is right here. 12 over 7, that's way more than 1, right? So 12 over 7 is over here. You know that x has to be greater than 3/5 and also greater than 12 over 7. So it can't be in here. So the overall restrictions for the question are x must be greater than or equal to 12 over 7. And that's how you get that. So it's where it overlaps. That's the domain. It's called domain. All possible values of x is called domain. So, and I don't think we focus too much on that. So there you have it. Now you know that. So do your restrictions separately, and then where those domains overlap, that's going to be the answer. All right. I think we should do one more. Let's do one more where we have two. Let's do D here. So I'm actually just going to, give me a second here. I'm just going to clip D out, give me a new screen here. All right. So in D, I've got this radical all by itself. So that's great. I'll square both sides. I'm not going to get rid of the radical over here, though. It doesn't look like. So this is going to be 8 minus m over 3. And this is going to be, if you want to write it out like this, go ahead. Do the FOIL method. So that's just 3m. Minus 4 root 3m minus 4 root 3m is minus 8 root 3m plus 16. So you got a bit of a jumble there, and you see that you do have a radical still. So we need to isolate for that one and then do that process again where we square both sides. Then we should be good. So we'll gather some like terms if we can. Subtract 16 from both sides. Gives me a negative 8 over here. I've got an m over 3 and a 3m. So I guess if we subtract 3m from both sides, well, what's that? That's, come on now. So that's 9m over 3. So that's minus 10m over 3. (3m) is 9m over 3. So that's what I did over here. So negative 10m over 3. Equals negative 8 root 3m. So I have to divide everything by negative 8. So just a refresher on the fractions here. Well, you can actually divide both of these separately, right? By negative 8, so that works. So this is a 1. Negative and a negative is going to be a positive. And 10m divided by 3, also divided by 8, is going to be 10m over 3 times 8 over 24. So if you have a fraction divided by a number, you can just multiply the two numbers in the denominator. Or think about it like this, times 1 over 8. You see that? Because this is 8 over 1, so you flip and multiply. The 8 and the 3 are down in the bottom. Equals root 3m. Okay? Any questions there so far? This is a long one. This is a long one. One of the tougher ones you'll get. You can simplify this fraction, I guess, if you want. Was it 5 over 12, I suppose? It's going to make things a little bit easier, probably. 5m over 12. Now we'll square both sides. So, oh, actually, what? Yeah, you could have multiplied everything by 12 too to get rid of a fraction if you care, but that's okay. So this is going to be 1 plus 5m over 12 plus 5m over 12. So that's really going to be plus 10m's over 12, I guess, right? Or plus 5m over 6 is how it's going to, when you add two of these. And again, I'm just shaving off some steps here for time's sake. And then we've got plus, and then when we square this, it's going to be 25m squared over 144. And then 3m over here. All right, and we're still going. Not quite done yet here. I see that I'm going to have a quadratic, so I should multiply everything by 144 to get rid of this. Probably would be a good idea, and then I'll gather some like terms. So times 144 to get rid of my denominators. 144. So 144 divided by 6 is 24, I think. Right? 24 times 5m. Somebody check that out. 144 divided by 6. Should be 24. And this is going to be 25m squared equals 300, 420, 432 m. Okay, I know this is a long question, but keep at it. You're almost done here. We're almost done. So let's gather some like terms. I've got 25m squared. If I subtract 32m, so this is going to be 120m. So 120 minus 432m is going to be negative 312m, I believe. Plus 144 equals 0. All good so far? You guys are double checking my mental math here? It's early in the morning for me too, so you guys might have to double check. Now at this point you have some options. Quadratic formula, you can plug in the quadratic formula, or you can graph it. If you have a graphing calculator, you can throw this into y equals, find the intercepts. You could factor it, you could complete the square, you could do all sorts of things. It's just a quadratic, so you have all sorts of skills to solve quadratic. So let's plug it into a quadratic formula. All right, so your two answers should be not 21. It should be 12 and 12 over 25, and this one should be rejected, extraneous. So here's your answer. All right, that was a really long one, but that would be probably the most complicated one that you would have to work through. Just get on your calculator, do one step at a time. This is where you need to start showing your work, right? Make sure that your work is shown, and also double check your answers. Okay, any questions about anything we did here today so far? Yep.
Sorry, this is kind of early in the question.
Yep.
How did you get 10m over 3 again? Did you convert the 10
Good, good. Okay, so earlier in the question, where did I get 10m over 3? Oh, see this one right here?
Yeah.
So what I did was I took negative m over 3, and then I subtracted the 3m from this side, see? And then, so when you put the 3m as a fraction over 3, then you get this over here on the right, you see? So that's negative 1m minus 9m is negative 10m over 3.
Oh,
So I'm just,
now I get it.
so I'm combining this term and this term really. So I'm moving those together. Okay? Good question. Anybody else? All right.